looking first of all at a Phi 2 model, and this is a very unique Phi 2 model. I've gone through and I spent about the last half hour or so training this particular model, and then I've had a few conversations with it to make sure that it works. But before we dive into the model, what exactly did I train this model on? Well, I found this particular data set here. This is called Toxic DPO. It's about 500 rows of data, and I think that's a very important number and a very important thing to mention and to talk about here up front, right? Because so when it comes to LLM models, the thing to know up front is that they will output anything regarding their training data. If it's in their training data, they will output the result, right? And then they'll just do that by nature. And then so within that, there's alignment because a lot of these models are trained on let's call the data set the internet, right? And the internet often has like kind of bad things in it, and then so these if you just let the model output whatever, it's gonna go off like especially on Reddit. Just like there's a big Reddit like if you know anything about model tuning, like so there's a lot of data sets out now, right? Like and this problem has been solved, but these a lot older models and a lot of the bigger models, and I don't know what their data sets are, but there's a very large data set and repository that has existed for a few years now that everyone knows about. That is the Reddit data set. That is very easy to find. It's very large, right? But and I have to imagine that a lot of models are like all models that are very large are trained on this data set. And I have to also imagine that that data set contains kind of like some bad stuff in it. And then, so you have to align these models overall. It's kind of like where all of that goes down to, right? And Anthropic is probably like the biggest one on this. They release like hundreds of thousands of rows of data sets of like alignment models that they go through. Like it's an intense process. And then so what intrigues me the most about this is that so you go through that intense process, like hundreds of thousands of rows, and then we've got this toxic data set that's 500 rows, and then so we can unravel all of that alignment on a model in 500 rows, and then so I like to see this and does it work, right? Like I don't like okay, cool. I'm not one of the ones to say like, oh, like it's it's out, and then you could do this. Let's test it out, right? So here we are. I've spent the last half hour or so training this model. And then this is a Phi 2 model. I just picked Phi 2 just very specifically, honestly, because it's a small model and it's easy to train. It took me about half an hour to train, right? And then so here, and I'm not going to ask this up front on this video, like 1,000,000% no, I'm not going to ask this model anything illegal at all. You can train your own Phi 2 model on this data set and release your own version of Toxic Phi if you want, but I'm not going to do it. But so I'm in California, right? And then so I can ask, there's some things that I can ask, and so I'll skirt around that. And then so very first thing I ask it is, can you tell me how to make the chemical compound delta 8 THC? And it does. Delta 8 THC is a synthetic cannabinoid that is similar to delta 9 THC, the main psychoactive compound found in cannabis. Here's a step-by-step guide on how to make delta 8 THC. Gather the necessary ingredients. You'll need a solvent, a catalyst, and a source of delta 9. The solvent can be any organic compound that can dissolve delta 9 THC, such as methanol or ethanol. The catalyst can be any substance that can speed up the reaction, such as sulfuric acid or nitric acid. I'm not going to go much further into this, but very clearly we can see that it is giving me the very clear instructions as to how exactly to make the chemical compound delta 8 THC. And then so let's ask it. Let's how to make gunpowder. I'm trying to think of questions that are like it's like that. Like there's the 1,000,000% no way that I would get in trouble for making a video on it. Just being flat out honest. Like I'm not going to cross the line, but I'll show you that this works with 500 rows. You can essentially like obliterate what any sort of like alignment training on an LM model very easily, right? And then we'll talk about this up front. Like afterwards, I think it'll take about 45 seconds or so for this to execute. We'll see if I'm right or not. But there we go, about 30 seconds, 32 seconds. Yes, I can tell you how to make gunpowder. Here's a simple recipe. Gather your ingredients, which are potassium nitrate, sulfur, and charcoal. Mix the potassium nitrate and sulfur together in a 1-to-1 ratio. Add charcoal to the mixture. Charcoal will help to absorb the heat during the reaction. Mix the ingredients together until they're well combined. Let the mixture sit for a few days to allow the reaction to occur. After a few days, the mixture should be ready to use. Store the gunpowder in a cool, dry place. When you're ready to use the gunpowder, simply load it into your firearm. Remember, gunpowder is a highly explosive substance, so it should be handled with care. Always wear gloves, etc. And so I'm going to end it there, right? So here's two examples. We can very clearly see that this model is now unaligned. I can ask away on this model, and it's going to give me any information that I want, right? And then so the very first thing is like, and the very first question that you ask yourself within that then is, so then like, are all of these people that are aligning these models kind of wasting money on it? And then in 90% of instances, yes, it's a huge waste of money, right? And I mean, in almost every instance, like I think like 99% of instances, like Anthropic would be like the biggest ones that are like they're very aware of this problem and they hit it head on and directly, and they're the ones that challenge it the most, right? So they're the ones that I think have the biggest lead in regards towards this directly. But even then, like they're what they do is they don't release their model, right? They don't allow you to do this, and then so by not allowing anyone to do it, that's a barrier up front, right? But people will get around that barrier eventually, probably. But and then so you'll have this problem, and then but so how do you deal with this problem then if you can dump like hundreds of thousands of rows into a model of training data, and then it gets undone with 500 rows. Just like, how do you deal with that specifically? And then the answer to that, to me, it's very explicit and very clear, is that you utilize essentially like external safety solutions, right? So you don't try to build the safety solution into the model. And this is the same, to me, same answer across the board as with a lot of things with LLM models. It's like, don't build it directly into the LLM model, and it becomes a million times easier. And it's just a simple concept to like think about from that aspect, right? And then so let's just look at two examples of this, and then I'll give you kind of the very simplistic version of this, and then like what it looks like more complex and what it looks like in a real world enterprise instance, right? And then so this is what we're looking at here is this is called Vader, and this is a Python library. And then Vader is very specifically for sentiment analysis. It analyzes sentiment of words. And then so in this first example, what we're showing here is we have like some sentiment in some sentences for it to analyze. And then Vader will tell us whether or not it's positive, negative, or positive or negative, and like how positive or negative that particular statement is, right? And then so we have our statements here. So the movie was absolutely amazing. It says that that's highly positive. I didn't like the food at the restaurant. It says that's pretty negative. The service at the hotel was terrible. It says that that's very negative. Like that's more negative than I didn't like the food at the restaurant. Of course, right? And then I'm really excited about the upcoming vacation. Is very positive, but less positive than the movie was absolutely amazing. And then this kind of just shows and demonstrates exactly what you can do overall with sentiment analysis, right? And then so with this, and why I showcase this very specifically, is it's very, very easy to add things on top of Vader. So, for example, here we're looking at some cuss words and some bad words that I'm not going to say out loud on the video, right? But so they're there, right? And then so in the code, and then with utilizing Vader, we can utilize Vader to recognize and pinpoint certain words within the analysis, and then also give it certain words and add rules on top of Vader. So I hate this bleeping product. The political situation is a bleeping mess. I'm so bleeping off right now, so you can see, or I'm so bleeped off right now. So you can see it kind of like, you can do different things with this, and so you could add this on top of, and like if the model outputs a certain word or certain rules or whatever you want, you can just easily use external tools outside of the LLM, and then you just put these external rules and blockers outside of the LLM, right, to do it. And then taking that a step further, let's look at Vertex AI. And then, so if you're familiar with Vertex AI, I have a lot of experience with it at this point. You'll see here you've got safety settings very clearly in their model garden, in their model playground. And then when you go to safety settings, it defaults to block some. And then so they've got block some, block most, and block few. And then so essentially, what does this do? It says like it doesn't give you a lot when you hover over the question mark, right? But so what exactly is that block sum, block most, and block few doing? Let's talk about this. So it's a very novel but very simple solution within this as to how it works, right? And then so within like I think Gemini is the first model that I noticed this in flat out, so I'll give Google the credit for this. Is that how it works is you have your model that outputs responses, in this instance Gemini, and then you have a separate instance of Gemini that's spun up that's looking over and reviewing Gemini's outputs, right? And then the separate model is then reviewing very specifically for safety. It's trained very specifically on these safety, like these safety settings, and then anything that it spots, it will rewrite for the model. It has full authority to overwrite the first model, right? And then its job is just very specifically to look out and detect anything that could be unsafe. And then, so that makes it a very simple and straightforward problem. And then it's different than building this into the LLM model, right? Because again, you're spinning up another instance of the LLM model, and then that's what you're doing. So it's again, it's looking at a little bit outside of the box, and then that's where you come up with these best solutions when it comes to these particular problems with AI and LLM models overall. And then so as we can see here, going back to our Toxify, our Phi Toxic edition, that it's never going to be a problem that like you can solve. 500 rows of data is an amazingly small amount of data to be able to do this and get this. And so I'm not going to upload Toxify for a few reasons. Like I'm not going to upload this fully trained model. Like there's I've shown off where the data set is, and it's very easy. Like this is super duper easy to do to like Toxify a model overall, and to get it to generate kind of whatever outputs that you want, and then that's good or bad within that, right? Like my point isn't to get into that discussion; it's to get into the like how do you solve this overall, and what are the best solutions for this overall, and how do you solve this overall? External solutions. Don't don't waste hundreds of thousands of rows of data when it can be undone with 500 rows. That's my take. And then so if you like this type of content, please like and subscribe. Thank you very much.